Welcome all to Work Energy and Power Class 1, in which we'll discuss about work. Work is nothing but a transfer of energy. So whenever we are doing some work, so we are basically transferring energy from one form to another form, or whenever a work is happening, then there will be a transfer of energy from one form to another form. Now let's see how we will calculate the value of work done. So assume that there is a force F is acting on the object, and because of this force, let's say this object is displaced by some distance. Assume that displacement happening to this object is represented by nothing but S. So over here we'll write the value of work done is equal to nothing but the value of force and displacement. The product of force and displacement will give the value of work done in a situation when the force and displacement are in the same direction. Now just consider another situation in which the force is acting along this direction and the particle is displaced along this direction. So this one is representing the displacement of particle and this is the direction of force. So over here, if this force and displacement are making some angle, let's say that is equal to theta, then in this situation we cannot write the value of work done is equal to force into displacement. So we need to find out what about the component of force along the direction of displacement. So we can write component of force along the direction of displacement is nothing but F cos theta. So over here we'll write the value of work done is equal to nothing but F cos theta into the value of displacement. Or we can do it in the other way. That means if displacement is along this direction and force is acting along this direction, then when we can calculate what about the component of displacement along the direction of force. So component of displacement along the direction of force is nothing but S cos theta. So we can write the value of work done is equal to F into component of displacement along the direction of force. So in general, work done is not just the product of force and displacement. It is the product of force into displacement along the direction of force. That means either you can write it is displacement into component of force along the direction of displacement. That means we can write it as nothing but F cos theta into S, or you can write it like this. It is the product of force into component of displacement along the direction of force. That is nothing but S cos theta. So we'll write over here the value of work done is equal to F into S cos theta. So overall the magnitude will remain same, that is equal to Fs cos theta. So we'll use this general equation. Work done is equal to F vector dot S vector. As we know that A dot B is equal to nothing but AB cos theta. F dot is equal to nothing but Fs cos theta. Now for the better understanding, just consider a situation that we are exerting a force F along this direction and this object is displaced something like this. Okay. Now in this situation, if you want to find out the value of work done by this force, so some students by mistake they will take it is a product of force into displacement of center of mass. Just remember that this work done is not equal to the product of force into displacement of center of mass. Work done is the product of force into displacement of point of application of force. That means this is the point of application of force. We need to always observe what about the displacement of point of application of force. So just remember that work is a product of force and displacement of point of application of force in the direction of force. So remember that work is defined as a product of force and displacement of point of application of force in the direction of force. And this for work done is a scalar quantity. That's why we are writing in terms of dot product. Now just remember that this work done is a scalar quantity and its magnitude we'll find out by using this equation Fs cos theta, where theta is the angle between force vector and displacement vector. Now depends upon the value of theta. That means if the value of theta is less than 90 degree, then the value of cos theta will be a positive value. So as the value of cos theta is a positive value, we can say that the value of work done will be positive. And if the value of theta is equal to 90 degree, then we can say that the value of cos 90 is equal to nothing but 0. Then the value of work done becomes equal to 0. And if the value of theta is greater than 90 degree, then the value of cos theta becomes a negative value. Then the value of work done will become negative. So remember that this work done can be positive, negative or 0, depends upon the value of theta. So remember these important thing: if the angle between the force vector and displacement vector is less than 90, then the work done is positive. And if the angle is 90 degree or force vector and displacement vector are perpendicular to each other, then work done is 0. And if the angle between force vector and displacement vector is more than 90 degree, then work done is negative. Now let's see how we'll calculate the value of work done if force is a constant and if force is not a constant. If force is a constant, then for the calculation of work done, we can directly use that equation, that is force into displacement into the value of cos theta, or again use that equation F vector dot S vector. Now if force is not a constant, then we'll consider that for a small displacement of, take it as ds, we can write the value of work done, let's say that is represented by dw, that is a small work done for a small displacement ds, will be equal to F into ds. That means we are assuming that at this instant force acting is F, and for a small displacement ds, the value of work done can be written as nothing but F dot ds. Now if you want to find out the value of total work done, we'll go for integration of dw. So we can write that is integration of F dot ds. So integration of F dot ds within the specified limit, let's say from S1 to S2, will give the value of total work done. So if force is not a constant, we should use this equation. As the value of work done is integration of F dot ds, so if you are just drawing a graph just showing the relation between force as a function of displacement, then remember that area under force displacement curve with respect to the displacement axis will give the value of work done. So the another way to find out the value of work done is nothing but area under force displacement curve. So area under force displacement curve will give the value of work done. Hope so that you understood what are the things we discussed in this class. If you are having any doubt, please contact. Thank you.